So in this video, we're going to take a look at angles inside triangles. And the rule to remember is that the interior angles inside a triangle always add up to 180 degrees. Now, that in itself is very interesting, very useful, but we can also use that with a few other facts to often find different angles as well. Because from our work on straight lines, opposite angles, if we know this angle A, well, we could find this one, this exterior angle, by doing 180 take away A. And of course, if we know A, well, this angle opposite A is going to be exactly the same thing as A as well. So there's always ways we can use these triangles to help us find even more angles if we need to. So other things that are of note, if we are told that something is isosceles, it means that two sides are the same length. And often that can be denoted by a dash on both sides, or in some cases, a double dash like this. That means that the sides are the same length, right? But that has a knock-on consequence, because if these sides are the same length, it also means that we have equal angles here. But be careful which angles you decide to make equal. It's always going to be the ones that follow a sort of line of symmetry. If we imagine this is symmetrical, well, that means that this is the same as this. Well, this will be the same as this. And we've got to make sure we think of that symmetry in the correct place. Now, if we have an equilateral triangle, that means that all the angles are the same. So we can find them very easily, because once we know that we are equilateral, it means that they've all got to be 60 degrees, because they have to be the same. We couldn't have any other answer, because they have to add up to 180. So we designate all the sides the same and all the angles the same. And just be aware, scaling triangles, we can't really use any of these clever tricks. We don't know any sides and any angles, just that the angles add up to 180 degrees. So let's see some examples and see how we can use this. So first of all, nice and simple, we've got to work out the angle A. Well, we know all three of the angles inside that triangle add up to 180. Well, 70 plus 50, well, that is 120. So all we've got to do is think about how much is left over to give us angle A. So I do 180, take away 120, and that leaves us with 60. So angle A is 60 degrees. Okay. So let's, in this question, find the interior angle remaining, but also that exterior angle, the B in both cases. So in part A, we should work out what's left over after we've got 62 and 63. Well, that is going to be 125. So in order to find that A, we need to do 180, take away that 125 to see what is left over. Well, we can do that. That is going to be 55. So A is 55. Now, to find the B, well, we know that angles on a straight line add up to 180. So that A and that B combined is 180. So to find B, I could do 180, take away 55, and that'll leave us with the answer. And that is giving us that 125 again. B is 125. Now, in B, we've got a similar sort of thing to work out. Now, when we see this symbol here, this square, that is going to mean that we have 90 degrees there. So this one is very similar to the last question, but we've got a 90 and a 42. So 90 plus 42 is going to give us 132. So in order to find that A, that we've got to work out what's left over after we've used 132 out of our 180 degrees. And we can do that. That's going to be 48. Right, so A is 48. Then to find out B, just like last time, we know that we have a straight line here. So the A and the B combined around that point must be 180. So if I do 180, take away 48, I'm going to be left with B, and that is 132. And we're done. Hopefully that's going to help. Let's move on and have a look at one more challenging question. So here we've got all sorts of things going on. Let's see what we can do. Well, first of all, we know that we have a isosceles triangle. Those two lengths marked are the same. Now that means that angle B and C are also the same. So we can use that in a moment. First of all, though, let's find angle A. Well, to find angle A, we know that the 130 in A must make up 180 because they're around that point there. So we do 180, take away 130, and that's going to give us 50. So A is 50. Now, to find B and C, well, we know if we do 180 take away 50, we are going to get 130 again. And this must be both B and C added together. So B and C added together are got to be 130 because that's what's left of the 180 inside that triangle. But they're the same because of this isosceles triangle rule. So what we can do is just work out 130 divided by 2, and we can get that answer. And if we do 130 divided by 2, we're going to have 65. So both B and C are 65. Finally, we can think about D. And again, this time we've got that C and D add up to 180. They're around this point. So if I've already used 65, then if I do 180, take away 65, we're going to have our answer. That's going to be 115. I hope that helps you to answer some questions about triangles, and I'm sure you can do the exercise now.